Good morning, everybody. I want to make sure. Nice. My voice coming through. Most importantly, good morning. What's up? Morning, Jude. Good morning, Samir. Who watched the last video now? The one that I uploaded. I watched the last video I uploaded. It was on solving equations where the variable is on the denominator. Supposed to be easy peasy lemon squeezy. Tamana, watch that video? But I did. That video important. Anil, Jude, Samir. Tamana. Talk to ma. We're waiting for Anil. He's sticking, man. Sticking bad. Now is not the time to stick. All there, boy. Now is not the time to stick, fellas. Yeah, get the time to watch it. Boy. You had to make the time. Condemn thing important. Alright, so just make sure another one watch it, right? Just make sure and watch it. Now, I will just do a quick thing, right? I will just do a real quick thing. All right, 1 second, right? I'm gonna just fix it here. Give me a second, right? Let me just fix it. Right, I'll be here, my dear, now. Yep, it's supposed to be here, my dear. All right, well, I know all of here now for sure. So, like, I'll recap then. Last week before, we learned how to solve linear equations, but in all of those equations, the variable is on the numerator. Last week, we did examples where the variable was on the denominator, and it just took two simple steps. In some cases, the first step was a LCM, and the second step was a cross multiplication. So in a case like this, where we have the red writing, I'm allowed to cross multiply because I have one fraction on each side of the equal sign. I'm allowed to cross multiply because that happened in there. If I don't have a fraction on each side of the equal sign, well, I had to find LCM first. Because at the end of the day, LCM is a method in which I can represent more than one fraction as one fraction. So that is what we did last week. And I left you with our last example, so I'll need to watch over that one in order to move forward. Right? So today, what I want to talk about, I want to talk about something called coordinate geometry. Right? And let me do a new setup. Okay, right? We're going and talk about coordinate geometry. A lot of you would have been exposed to coordinate geometry at some point in time. At least in Form 2, Form 3, whatever point in time I was exposed to it. Now, coordinate geometry is a branch of mathematics that deals with plenty graphs. And with graphs, we call the graphs the Cartesian plane. The Cartesian plane is also called the XY plane. Right? It's just a different way to call the planes. So we could just use the notes from my last class. So here, the Cartesian plane refers to the xy axis, and points can be plotted on the xy axis, and they can be read from the xy axis. Now remember, xy axis and Cartesian plane are the same thing, right? It's just a different way to say it. We have the y-axis. The y-axis runs vertically. The x-axis runs horizontally. Now, on my y-axis, I'll have my origin, which is here. I'll have my x-axis, but my x-axis is actually split up into two. It's split up into the positive x-axis and the negative x-axis. Numbers on the x-axis, they go from 0, they go positive. So 1, 2, 3, 4, 5, 6, 7, all the way up to infinity. The same thing for the positive y-axis. It goes 1, 2, 3, 4, 5, all the way up to positive infinity. The negative x-axis goes from -1, -2, -3, -4, -5, all the way down to negative infinity. And the negative y-axis goes all the way down to negative infinity as well. Now, points can be plotted on the xy axis, and points can be read off the xy axis. When I'm plotting a point, I have to plot points in the form x, y. A point consists of two coordinates, a x and a y coordinate in the form x, y. So let me plot some points and then let me read off some points. If I have a point, and let's say the point is 2, 3. Well, 2, 3 is in the form x, y. If I have 2, 3, that's in the form x, y. So what do? I look for my x value first, which is 2. Then I go up and I look for my y value, which is 3. So if I were to plot the point 2, 3, 2, 3, I get the point 2, 3 on my graph. So if I zoom in a little bit here, maybe you can see it a little better. This is the point 2, 3. If I want to plot the point -1, 4, it will be when x is -1 and when y is 4. So if I plot the point -1, 4, I'll get the point when x is 1 and y is 4. Now, the reverse works as well. If I want to read off a point on a graph, and let me say I just put in an arbitrary point over here, point C. I need to check and see what is my x coordinate for C. C has an x coordinate of 6 and a y coordinate of 4. So the point C will have coordinates 6, 4. Now, 6, 4 is a point. 1, 1 is a point. -4, 2 is a point. And I'm going to put a point here and I want you all to tell me what the coordinates of the point is. What are the coordinates of the point F? So I'm going to continue talking. When I get the point, put it in the chat for me, right? Now, I have plenty points here. A, B, C, D, E, and F. And I need to figure out, well, not need to figure out, right? Coordinate geometry deals with the graph. And anything we can draw in the graph, we must have a relationship, a mathematical relationship for them. So the first thing we will learn to do in the xy axis, after plotting points and reading off points, we had to deal with straight lines. Now, a straight line can be drawn between any 2 points. So if I connect to any 2 points on this graph here, I'll get a straight line. So if I connect the point A to B, that's a straight line. If I connect A to C, that's a straight line. If I connect E to D, that's a straight line. If I connect A to F, that's another straight line. If I connect D to C, that's a straight line. D to, oh shucks. D to B, that's another straight line. Right? So 5 minus 2. Yes, Anna, that's correct. So I can draw a number of straight lines here. So I need to ask Alia a question. Deleting everything here, right? I need to ask Alia a question. What do I need to draw a straight line on my graph, apart from a pen and a pencil? See if you could answer that question. Pause the video and see if you could answer the question for yourself, and I'll give you the answer in a couple of seconds. What do you need to draw a straight line? What information do you need? Look at all these straight lines I drew just now and think about it. To draw a straight line, I need 2 points. The point A connected to point B will give me a straight line. The point A connected to C gave me a straight line. So I need at least 2 points, to draw a straight line on my graph. So those notes are translated here. A straight line can be drawn by joining any 2 points together. A line segment is formed when we join 2 points. Now, I want to talk about this definition called a line segment. I'm going to draw 2 points here, right? I'm going to join the point A and the point B. And I'm going to connect A to B. So you see A to B has a start point and an end point. AB is referred to as a line segment. an aligned segment is part of a line, because you will learn that the line AB is actually a piece of a bigger line, and I'll draw the bigger line. If I draw, you see the difference between segment and line. If I draw the line AB, this entire line is the line AB, and this fella going all the way up to infinity to the right and all the way down to infinity on the left. So a line segment is part of a line, and the line goes from infinity to negative infinity. Now, with respect to lines and line segments, there are this, delete this. With respect to line and line segments, we have a number of properties of straight lines that we need to learn. The first property is called the gradient. The gradient is extremely important. Now, what is the gradient of a line? The gradient of a line is a number that tells us how steep a line is. We can calculate the gradient a number of ways. Now, I'll show you just one way, because you all don't need to know all the ways. I'll just show you all one way as an introduction. When we get good at it, I'll show you the rest of ways. So I'm going to just plot these 2 points, 3, 6, minus 1, 5. 3, 6, 3, 6, minus 1, 5. This is the line segment AB. So let me just fix A. Sorry. A was 3, 6 and B was minus 1, 5. Oh, I put minus 1, minus 5 just now. My bad. A, B. Now this line A, B, it has a gradient. Now the gradient just tells me how steep a line is. The steeper the line, the bigger the gradient. So for example, if I give you all a little practice here, right? Let's say this is a straight line. This line is at a particular angle compared to this line, compared to this line, compared to this line. So as the angle changes, so too does my gradient. All right? And I can probably illustrate it for you all here. So if I were to show you all, and remember we said that the gradient is a number that will symbolize how steep a line is. The gradient of AB is 0.25. Now if I continue to, if I move, let me see if I can move it. Yes. As I move A, the line gets steeper. So the gradient increases. So you'll see how the gradient increases from 1 going to 2, and it keeps getting bigger and bigger and bigger. Going to 3, going to 4, going to 5. And as the line gets less steep, the gradient gets smaller and smaller and smaller and smaller. Yeah? What was the point? Something 6. Can I do one undo? Yes, I can. Good. So the gradient of this line as it stands here is 0.25. Now, how do I calculate the gradient of a line in terms of doing a calculation? It's very, very easy. I will reiterate the point that any point consists of 2 coordinates, a x coordinate and a y coordinate. So for example, the point A has an x coordinate of 6, has an x coordinate of 3 and a y coordinate of 6. The point B has an x coordinate of -1 and a y coordinate of 5. To calculate the gradient, we need a line. A line has 2 points. A point has 2 coordinates. So we need at least 2 points to calculate this gradient. So I'm going to calculate the gradient of this line that we have here. The gradient is given by a formula. And the formula is y2 minus y1 over x2 minus x1. And it's a very, very important formula. Oh Lord. Now you might be asking yourself, well, what is y2, what is y1, what is x2, and what is x1? Okay, why is not working? I'll do that. Let me just close off this one and open it back, right? Give me a second. All right, good. So like I was saying, the gradient of a line is given by this formula here. Very, very important formula. And we will ask ourselves, well, what is y2, what is y1, what is x2, and what is x1? You see points A and B? A is represented as 3, 6, and B is represented as minus 1, 5. Y2, Y1, X2, and X1 is just a way to represent the 2 points. Remember, point is represented as X, comma, Y. So the X1, comma, Y1 will represent 1 point, and the X2, comma, Y2 will represent the other point, because I need to distinguish between both points. So the first thing you all have to do when you all are calculating the gradient of a line is to label the points x1 and y1 and x2 and y2. Now it does not matter which one you label as x1 and y1, and it doesn't matter which one you label as x2 and y2. So if you look in the notes, the red working will be for the red labeling, and the green working will be for the green labeling. So I'm doing the red working first. Now the gradient, sorry to miss this out, the gradient of a line is symbolized as common M. In coordinate geometry, common M is the symbol to represent the gradient of a line. So the gradient of this line here, which is AB, I will represent it as M subscript AB. Now subscript means I write in this AB smaller than I write in the M. This is to symbolize it's the gradient of AB. The formula is given as y2 minus y1 over x2 minus x1. As long as you label your points properly, you shouldn't have a problem. The red labeling, y2 is 5, y1 is 6, x2 is minus 1, x1 is 3. So it's y2 minus y1 over x2 minus x1. 5 minus 6 is 1. Minus 1. Minus 1 minus 3 is minus 4. A minus and a minus will give us a plus, giving us a quarter. Or I can do the green working. The green working is with reference to the green labeling of the points. And the green labeling of the points, I labeled my first point x2, y2, and I labeled my second point x1, y1, opposed to the red labeling. And again, you just have to do one of them. Whichever one you choose to label as x1, y1, just label in x1, x2, y2. It doesn't matter. So the gradient of AB, in this case now, y2 is 6 and y1 is 5. x2 is 3 and x1 is minus 1. And this is where you have to be a little bit careful. The formula states is x2 take away x1. So brother man, use x2, u is the takeaway, and this whole thing here is x1. So you just have to be very careful when you label any points and putting them in the equation. Extremely important. And we get back a quarter as the answer. Alright? Very, very, very simple. Very easy to calculate the gradient of a line. Alright? Now, I don't want to dive into the properties of gradients as yet, because we are approaching the half-hour mark. about a half an hour I just want to take for the classes. I don't want to have too much of it to do. So there is what I want it to do for me for the next session we're going to have. So far we discussed the gradient and we discuss how the angle at which we draw a line represents the gradient of the line. So I'm gonna give a little bit of work to do here, right? Is that Kiran? Kind of weird how and what are not commutative but together. Kiran, I don't know what you're saying. So I'm gonna give a little bit of work to do for the next session we're going to have, right? These are the lines I want you all to just calculate the gradient for. And I'll put the points on the lines for you all. So let me actually put in the points here, right? I'm putting in 3 points. 1, 2, -1, -2, and -3, 5. So A, B, and C. So I put in the points. I'm labeling these points here, showing their values A, B, and C. And this is what I want all to do for me. Calculate the gradient of AB, 1. Calculate the gradient of AC, 2. And calculate the gradient of BC, 3. Now, I would like everybody to try this. I will do the answers for this now. When you're representing your answer for your gradient, I cannot stress this enough. You need to leave the gradient as a fraction. The gradient needs to be a fraction. Refrain from using decimals for your gradient, please, when you're representing it on your working. Now, in the app does not have the option to express gradient as a fraction. So what I want all to do, if I get the gradient to be 2/3, just check what the fraction, the decimal equivalent to it is on a calculator. Alright, so I'll tell you all what the gradient of AB is. AB is the gradient of AB. Okay, never mind. Why is this plane so mad, boy? Alright, so the gradient of AB is 2. The gradient of AC is negative 0.75, and to communicate that into a fraction it could be negative 3/4, but please verify it by using your formula. And finally, the gradient of BC is negative 3.5. So go ahead, do your working for this here. You can pause the video, you can go back and see what the formula for the gradient is and how to use it. In the next class, we will discuss the properties of gradients. Alright? And this is what I wanted to also do for the next class. We have different types of lines. We have 5 different types of lines we have to deal with and their specific gradients. Alright? Diagonal, vertical, horizontal, perpendicular, parallel. 5 lines. Diagonal can either go this way or can go this way. Either or. Alright? So it's kind of 6 lines we have to deal with and what goes on with their gradients. So in the next class, that is what we are going to do. So please use the notes, take down the notes, do the question, the answers are there. Again, the gradient of AB is 2, the gradient of AC is negative 0.75, and the gradient of BC is negative 3.5. So do your calculations, see if you get these answers. If not, comment on the video when it goes public, or you could put a comment on the Google Classroom for me. Alright, so please go ahead and do that, and I will see everybody So that's been half an hour. So later.